This is House Planning Help episode 247. Hi there, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build, because I'm exploring what houses we should be building in the 21st century and trying to break down the major roadblocks that may get in our way. Coming up in this session, my guest is Bill Butcher from Green Building Store, and we're going to be contrasting two of their radical retrofit projects. At the beginning of the podcast, just before we launch into the interview, I always try to share something useful, be it an event, a website, perhaps I've seen an interesting TV show, a resource. And that's why I thought, as we got Bill on, Green Building Store do an excellent job of sharing a lot of free information. And so I thought that that could be our resource for today, because on there, they've got blogs of various projects. Denby Dale back in the day, opening it up. I seem to remember I loved looking at all the costs as well. That was one of the things that they did in that early blog. Technical resources as well from their Sturley Community Barn, Gold Car Passive House was another case study as well. Just looking in some of the sections, you can dig into MVHR, things like do's and don'ts, where to locate MVHR units. So they've got lots of interesting things on there. Go and take a look, always updating it as well. That's Green Building Store's website. So Bill Butcher is one of the directors there, and he's been on the podcast before, way back in the early days. Would it have been in my first year? Possibly. And now we're coming up to 7 years into this. We've also featured some of their clients, Kate and Jeff Tunstall, also Angie and Paul Dallas. And so today we're going to look at some radical retrofits. And I know that we've been focusing very much on self-build, and I've ummed and erred a little bit about, well, could we do some more retrofits? I think where it's appropriate now, people have asked for it as well, we will feature a few of the highlights, because I've also seen the one that won the ASBP award this year. That's the Alliance for Sustainable Building Products. That was also a very interesting phased retrofit, which I think I would like to try and see if I can bring that one to you as well. So we're looking at two of their projects today. However, we start slightly off topic, you know me, with a discussion about traditional masonry cavity wall construction. The reason being that Green Building Store has delivered a number of their projects this way. And so I wondered whether this played to their set of skills as a team.
I do a lot of consultancy on design reviews, not going right through the passive house. And so much of a successful build is about what I call the comfort zone of the builder that you're going to be having a relationship with. It's more than just employing. When you're asking a builder to do something outside their knowledge base.
But Passive House, and you've had these builds over the last few years.
Yeah.
Are you still thinking that masonry is a good approach, or should we be heading more to kits, systems, anything that just makes it simpler to get it spot on?
I think for self-build, one-off dwellings, it has its advantages. Obviously, system builds, kit houses or off-site methods become cheaper with scale, economies of scale. For a one-off build, which has to take into consideration where it is, planning restrictions, and particularly client wants, if you like, aesthetics, it gives the builder with the masonry, basically you can get all the materials from your local builders merchants. He's got control, she has got control over the process far more than going out to a timber frame company, for example, and that's what we find, where there is a lot of more complication on a one-off build of that relationship between a large subcontractor as such with the timber frame, who is the main contractor, who's got control over it, and time-wise. So basically you can get on with it quicker if you're building with local materials. When I say local, blocks and bricks from your local builders merchants. So the swings and roundabouts. There is no one perfect way of building.
I wasn't suggesting there was.
No, they all work.
I am intrigued because obviously my own house is masonry, and I know that there are, well, I say it's masonry, I suppose, not entirely. It does have timber within it, timber trusses.
Yes.
Within the inside, you've got stud walls and this and that. But interesting on mine, and I've never really asked this question, probably of Chris and the team, but downstairs is masonry dividing up the rooms, and upstairs is timber. What would be the reason behind that?
Usually for structural reasons, in the sense that ground floor masonry holds the intermediate floor up. And also masonry is better for sound.
Definitely better for sound.
And with wet plaster, as we use for the air tightness, just gives a very solid finish that's going to last forever. But also the cave effect, your decrement factor. You've got a better decrement factor with block work. It's more even in temperature for obvious reasons, because it behaves more like a cave as opposed to a lightweight, i.e. timber frame. For example, on Denby Dale House with the massive southwest glazed area, that wouldn't have worked with timber frame. It would have overheated too much. But I feel it's down more to what your builder is used to.
So there is some control element, is there? That
absolutely, because it's teamwork. If your builder's used to working with brick and block, even though you've got a wider cavity, you've still got a strip foundation, which they understand. It might be wider. They still understand solid concrete floors on top of polyurethane insulation or XPS insulation. It's all materials within their knowledge base. So they are then going to price, if you're wanting them to put a fixed price in, reasonably. If it's a technology or methodology that they're not used to, an estimator, because it's them taking the risk, it's the builder taking the risk, it's their mortgage on the line, if you like, they're going to price tighter to something that they're confident with. And that is the main reason, I think, that people still build a lot of masonry passive houses.
Is there anything that could go wrong with a masonry build then? Let's say the team, not your team of course, is not quite so accomplished.
Oh, of course.
What are the things that could go wrong?
It's more a wet plaster, for example, is a dying art, because most builders want to do dot and dab, as they call it, which is gluing with dabs of adhesive plasterboard to the inner leaf of blockwork, which of course we know doesn't work in terms of thermal performance. We can't have that. And the main reason that they like doing that, the main contractor, is for speed and drying out of the building, because it's obviously far less water in the process. So wet plaster, if done properly, is fine. The disadvantage, one of the disadvantages, is that you don't have a service void, which you do or can do with timber frame methodology. And without going into great detail, what you're doing is channeling wires into the blockwork pre-plastering, particularly the electric boxes, back boxes to your sockets and your switches. That can be an area of failure. But otherwise, I think as long as you've taped the joins with the floor, the junctions with your window reveals and the windows themselves, I feel it's fairly safe.
Should we talk about a couple of retrofit projects that you've done? We mentioned Sturley Barn before. That was slightly different because you were using timber frames. So tell us about Cumberworth first.
Okay, Cumberworth. So much is to do with the clients and what they know and what they want. So Cumberworth was half a barn conversion and half a 1990s extension. So there were two halves to the building. So we had two strategies for the two bits of the build. But the basis of it was that it had been converted and built well in the early 90s, but there was no mains gas there. They were reliant on LPG for central heating. So they were spending £3,500 a year on LPG and was still cold. Because
how big is the building?
It's 150 square metres. Yeah.
Goodness.
Yeah, goodness. So they were cold as well. They also had a wood-burning stove in this. And they were pretty fed up. So they came to me to ask whether I knew anything about putting a wind turbine in the field, because that's the way they thought they could actually save on energy. So, no, you don't need to do that. Well, the best thing to do is get this house to perform better. But the trouble is you're ripping out value to do it. When I see a building which is in need of total renovation, it's going to be relatively cheaper to do than ripping out value of reasonable kitchens, reasonable bathrooms and so forth. Anyway, they were so fed up with where they were, but they didn't want to move because it's such a beautiful spot. So that was it. They bought the Fabric First philosophy and they moved out, rented a house and left us to wreck the place, if you like.
So when you retrofit, there is really a range of measures that you can do. So this is a deep retrofit.
This is absolutely deep.
Did you say Enerfit? Is this one?
No,
or did you set an energy target?
No, we didn't, because I knew how difficult it is to get the air tightness in a retrofit. We were lucky in that they were knowledgeable about the previous projects we'd done, and we know that if we get somewhere near Enerfit, it's transforming a building. So we use the appropriate materials and technologies for insulation, internal wall insulation, which is a whole subject in its own right, thermal bridging detailing, air tightness, and of course ventilation. So a full MVHR mechanical heat recovery system.
And you had to go internal insulation. Was that some planning constraint?
In theory, it could have had external wall insulation, but the buildings here in North Yorkshire, we really are in an exposed situation. That was another thing about Cumberworth and Lower Royd later. They are right on the top of the Pennines. They are really exposed to a lot of moisture. And actually, the natural stone that these buildings are built of around here suit that type of environment. And to build in any other way is totally out of character for this region. And that's what the customer wants. So you either transform the building with renders or timber cladding and outside. In some ways that it would make it easier to do a radical retrofit, but mainly it's internal wall insulation.
So what approach do you take so that you don't trap any moisture?
Right, okay, that's the big one, isn't it? So it depends on the wall build-up. In the Cumberworth case, we've got a 450 wide X-barn wall, which is basically two stone leaves with rubble filled in the middle, so there's no cavity as such. So and your moisture danger is rising damp, because we've no DPC in a Victorian barn, rain-driven damp, particularly where we are in this high exposure region on the Pennines, with a porous stone. And then the third moisture risk, of course, is interstitial condensation, which is the condensation of internal moist air reaching the dew point is where it turns to water as it meets a cold wall. So if you put an internal wall insulation on it, you are, by the very nature, making the masonry colder. So we use a software program called WUFI, capital WUFI, German software program, to actually model the wall to see what risks, moisture risks there are, which takes into account where you are, the orientation of the wall. Obviously a west wall up here is in more danger than the east wall. So most of our rain comes from the west. The rising damp, the type of stone it is, which quarry it's from, the mortar joints and so forth, and then obviously the insulation strategy you've got inside.
So these programs we've talked before about PHPP and so forth, they're pretty comprehensive. You've mentioned a number of variables. Yep.
Well, it's certainly better than what we've had before. The standard methodology has been the glazier system, which isn't as sophisticated, or we feel isn't as sophisticated as woofy. Even that can fail, so we've actually, on all these projects, we've got, because we're pushing the boundaries, we've got moisture sensors in the walls, so we can make judgments on their performance. And I might say that all the buildings are performing fine. That's right.
It's always a relief.
It is a relief. It is a relief. Yeah, we do stick our necks out. We do.
What else do we need to know about the strategy for this retrofit? We talked a little bit about insulation, that internal...
What I didn't say, Ben, was that the 1990s part of the project is a cavity wall, 1990s. So the risk is less. You've got DPCs, so you don't get rising damps. You've got a cavity, albeit not a brilliant cavity, but a proper cavity. So you shouldn't get rain-driven damp. So in effect, the only danger then is interstitial condensation of the condensing of the internal moist air onto the cold wall behind the insulation. So we ended up using a different strategy, simpler strategy, and less expensive. So each wall type can have a different strategy for internal wall insulation.
And it just has to link up carefully.
Oh, very much so. So you design to have continuity of insulation as much as possible. Easier said than done with retrofit. Continuity of air tightness strategy in all the elements, floors, walls, windows, roof. Again, easier said than done in retrofit. So we're not looking for the same air tightness results as we are in new build. New build is easy compared to retrofit.
And one of the big ones is what's below as well. So were you changing anything beneath? You mentioned no damp-proof membrane or anything.
Right, yeah. Well,
insulation, I suppose, is probably the big one.
In Cumberworth, because we don't get down to the energy demand we can in new build, we certainly needed a heating system. And the client wanted to go for underfloor heating. They also went for a ground source heat pump. They happened to have a very boggy field in front of the house, which was very good for ground source. Air source and ground source heat pumps were the most efficiently at delivering 35 degrees C water, hot water, if you like, for your central heating system. And that suits underfloor heating more than radiators. And that then informs how you do the floor. Because we don't want to be heating up masses of concrete in a floor because of the slow cooling and heating.
I was going to say, generally, for new build, you're warded off, aren't you?
You are indeed. But with a big retrofit, your heating demand is something like, at best, 25. It might be 35, 40. And your walls are a U value of 0.3 as opposed to 0.15. So you can see that it's not at the levels of new build. So underfloor heating becomes more relevant, I think, with these retrofit jobs. So you tend to build with a concrete slab on the ground or on hardcore. So you dig out what's there, damp-proof membrane, concrete slab, then your insulation, in our case 200 millimetres of polyurethane or XPS, and then your 75 mil heating screed on top. So you're only heating up 75 mil of screed, not the whole slab.
Do we get to the easy bit then of the roof? Normally,
the roof's relatively easy compared to everything else in a retrofit.
Compared to everything else in a retrofit. Yeah.
Yeah. Is it a cathedral roof or is it a cold roof? The difference being, is it in the line of the roof, pitched roof, or is it in your flat ceiling? In the Cumberworth case, well, in fact, in most of our retrofits, we have cathedral roofs, so we tend to have our insulation within the actual structural timber roof. What we tend to end up doing is almost having a stud work parallel with our rafters, if you can get what I mean. So we end up with insulation between the rafters, insulation again, and then within the stud work, if you like, which is between the purlins, more insulation. So we would use more rigid bats between the rafters, mineral wool in our case, and the stud work, and then just an ordinary loft fiberglass insulation between. So we're building up to a U value. We can get right down to something like 0.12, which is new build standard. So yes, in answer to your first question, it is easier to get to that U value and the air tightness actually.
But still quite a bit of work on the roof.
Oh, load of work. Of course, yeah, this is a deep retrofit.
Ventilation then, was this a slightly easier part of the project?
Yeah, it was actually. Although, of course, it's intrusive. MVHR is, big pipes, a big machine, relatively. So we built a plant room as part of the alterations to the building. And then you've got to run ducting. In a new build, it's relatively easy because you can build with quite deep intermediate floor, particularly with the posi joists, the metal ones, if you like. So you can run in a new build all your ducting within that space and then distribute it around the building. With a retrofit, that's not the case. You don't have that luxury with your intermediate floors. So you have to be quite savvy. Quite often we'll run it in the corridors of a house where you don't mind lowering the ceiling. It's not noticeable. Anyway, we did it, and you can do it, and it's working at the 94% efficiency. It's brilliant.
Well, that's obviously a big strength of Green Building Store, isn't it? Having your
indeed.
ventilation department on hand.
Yes, quite.
So we've covered a lot of the key aspects. Is there anything else we should mention before we look at how you moved on again for the next retrofit that came your way?
Oh yes, the windows, which was peculiar on this job. We'd actually replaced the windows 5 years previously with timber triple glazed outward opening windows, which we made at the time. So there was no way we were going to chuck them away, were we? So part of Fabric First methodology is that you get continuity of insulation, because if you do it well in 90% of your building, for example, the 10% becomes very vulnerable to condensation and cold bridging. So the reveals between the very good wall insulation we were doing into the window frame only allowed for a 10 mil insulation. So to maintain that U value that we'd got on the walls of 0.3, we had to use vacuum insulated panels, which look like coffee packs. So they're custom made, obviously, to fit. So they have a lambda value which is 3 times better than polyurethane, or 6 times better than the wall insulation. So we were able to use the vacuum insulated panels in the reveals underneath the window board and behind plasterboard, all taped in together, of course, for air tightness.
Just like a massive jigsaw, these retrofits, aren't they?
Yep.
You've got your different approaches.
Yep.
But when we move on to lower Royd,
Yeah.
you're starting all over again, really, aren't you? Or
We
how
are,
much?
yeah.
It's the same methodology.
Yeah.
But what are you going to tell me? Are we
well,
internal insulation
yes,
again?
Internal,
We are.
we are indeed, yeah. But we used a different strategy at lower Royd. One of the disadvantages with our rough stone walls we have here in the Pennines is that they're wobbly, and a rigid insulation, as we used at Cumberworth, which was a rigid perlite board from Germany called Tectem, was that you have to dub the wall out and flatten it, which actually takes more work than anything else. So we used a different material. It was from Italy. It's a spray, well, no, you can hand apply it, but we sprayed it a cork and lime wet process with a lambda value of 0.045. So it's as good as polystyrene or normal fiberglass or so forth, or wood fiber, sorry. But with the added advantage of that you didn't have to flatten the walls, so it was straight applied. So we built it up in 4 25mm layers. So that was both airtight, vapour and capillary open to all those moisture issues I talked about earlier on the barn at Cumberworth, and with a beautiful finish. Now, being a lime product as well, it inhibits mould growth. So it dealt with all the risks all in one hit.
So that's your airtightness layer as well,
Yes,
did you say?
Yeah.
Wow.
Yeah.
Were there any other quirks of this building? I realise we haven't described what it was to begin with. We're now on Lower Royd.
Well, the advantage of Lower Royd in terms of economics was that it was a virgin barn, so you've got nothing to rip out. And the farmhouse part of it, because we converted the barn and upgraded the existing farmhouse, which was really in 1960s state. There wasn't a lot of value in it. So we could completely start again.
That's the time to do this, isn't it?
It absolutely is, but they're rare to get nowadays. That is not reality for most of us.
So what else was different and what else was the same as we go through this second retrofit project?
Well, one of the main differences is the heating strategy. You remember at Cumberworth there was no mains gas. Well, we have that at Lower Royd. Even though we're out in the countryside, luckily for our clients, a dairy farm further up here in the Pennines had gas laid on, so they were able to take advantage of that. Now, the clients had assumed that they were going to go for ground source heat pump, but in terms of economics, for example, ground source heat pump may cost you 20 grand to get into the building, as opposed to gas and a standard boiler, and we're talking about the smallest boiler, condensing boiler, off the shelf from your local builders merchants, costing installed 1,500, 2 grand. You're better off with that saving of 15 grand, say, to be put into your fabric. The cheapest energy is the energy you save. That heating system can always be changed to an air source or ground source heat pump in the future.
So was there anything that you brought from the retrofit before into this one, new learning, or was it really you just have to do each one as it comes?
Well, you do the most appropriate in terms of economics and risk, moisture risk, particularly with internal wall insulation. So it was more the knowledge that we gained from Cumberworth was brought into Lower Royd, but the main difference was the internal wall strategy and what we used. And we now are going to be moving on later this year to a similar large barn conversion here in the village, another one in Meltham. And we haven't decided yet what internal wall insulation we're going to be using.
But another internal wall, it's interesting, yeah.
We'll always, well, the clients just assume that's what we're going to go for.
Maybe just as we wrap up, can you just take us through the stages that you go through in the retrofit, from design right through to construction? What does it actually look like?
Well, these processes always start with the client wanting a fine house, really. And nowadays, the general public are far more, in our opinion anyway, or a certain section of the public, are far more knowledgeable about energy and buildings now. And of course, with the climate change issues that we have at the forefront nowadays, people are really thinking about it. So if you're ending up with internal wall strategy, it really informs you that you can cause a lot of damp and mold problems within buildings if it's not done properly. What else have we learned? It's just ingrained in our personality as a firm nowadays. We cannot go back, actually, to how other builders are doing things still. And it's just a fact, really. We've only just got to carry on. What we've got to do, and what we try and do, is make it more economic. In other words, look at what we're doing, how we're doing it. Do we need to go that far? And in fact, we're looking at the issue of maybe putting less insulation on the wall. So we're sort of we're weighing up the advantages of a lesser U value on the walls for the saving, but still having the same airtightness and a good ventilation strategy. What we are finding is that the airtightness is probably, from an energy and comfort point of view, the first thing to be thinking of. And almost insulation comes second. It's more important to get a continuity of insulation. It's much better to have 50 mil of insulation everywhere, done well, than it is to have 100 mil insulation done reasonably well on only 75% of the building. It's things like that that you learn over time.
And what advice would you give to someone just thinking about a retrofit, wanting to research it, wanting to get the right design, right build? How can we leave this interview?
Well, either to read up on it yourself, talk to other people that have done it, get the professionals, designer on board, either to learn with you or has learnt already. Ideally with builders and suppliers, actually, who have experience, and basically tying it all together. A good retrofit is, as we said earlier, more difficult than new build. So we're looking all the time to try and simplify it, but you have to take into account there's been so much bad retrofit done over the last few years, and we really must take lessons from that and do it in a more, risk-free way.
Well, Bill, it's been fun to catch up again. Thank you for all your information. Much appreciated.
Thank you, Ben. It was lovely to meet you again.
Get more in our show notes, which you can find at houseplanninghelp.com/247 for this episode. Review the main information. Also check out some photos through construction and completion of Cumberworth and Lower Royd. And if you have a comment or you'd like to ask a question, you can scroll down to the bottom of the show notes. That's the place to do it. We'll link you across to Green Building Store's website, of course, with all those resources as well, as we mentioned earlier. To Bill on Twitter, houseplanninghelp.com/247. My call to action is to check out the Hub, and this is our vault of digital resources just so that you can dive even deeper, including the in-depth video case studies following complete builds. At the moment, we're turning around videos from my own house build, so I think we're out of the ground now, and we've got about 5 or 6 videos. And we will add another one each month. Courses, which are step-by-step, all the learnings that we've had through the podcast, and featuring a lot more video to help you digest in a different way. Perhaps you can find those things online, but maybe you don't have it in the way that you like to consume things. You can also download the audio if you choose and listen to it like you're doing now. We've got conference calls with experts. We have our office hours where you can just have a chat with me. Sometimes it's just bouncing around ideas. Sometimes I might be able to share a resource or someone that I think is in your neck of the woods and could really help you out. We've got the forum, which is our community where you can pose quick questions and also stay accountable. We love the progress log. I kept one of those through construction, so maybe you want to go and check out mine, what I was thinking at specific times during the process. houseplanninghelp.com/join. There we go. There's another one. Thanks for listening. The House Planning Help podcast is produced by Regen Media, content that matters.